Welcome to Data Talk, presented by IDEA Data and Research. DATA stands for Data Analysis Techniques Applied. Data Talk is a series of webinars for Arkansas's local education agencies on the use of data, particularly for special education staff. In this episode of Data Talk, we will discuss the context of the data, types of data, and descriptive statistics. In our last Data Talk, we mentioned that the wording of the question you are trying to answer will determine the data collected in the context of the data. You cannot collect the data for one question and then try to make it fit a different question. In Episode 1, we talked about two questions that had to do with speech, the difference between who is identified as having a primary disability of speech and who receives speech services from a speech-language pathologist. If you collect only data on students who have a primary disability of speech, you cannot determine the number of students who receive speech services from a speech-language pathologist. However, if you collect the disability code and who actually receives speech services from a speech-language pathologist, you can actually answer both questions. As your data knowledge increases, you will become more centered in your ability to relate the context of the data to the question, data collection, and analysis. Now let us talk about the types of data and how to apply descriptive statistics to the various types. There are four basic types of data: nominal, ordinal, interval, and ratio. Let us take a look at each type of data. The first data type is nominal. Nominal refers to categorical data, also known as discrete. There is no measure of distance between the values. Variables include such categories as hair color, marital status, gender, and so forth. Can you answer this exercise? Can the distance between the categories of a nominal variable be measured? Yes or no? The answer is no. The next type of data is a little more sophisticated than you can get with just categorical names alone. It is ordinal. Ordinal refers to quantities that have a natural order. Ordinal implies order, in other words, ranking. Ordinal scales both name and order. You can have higher and lower amount. Less than and greater than are meaningful terms. You do not rank male and female as higher or lower, but you do rank the levels of proficiency, higher or lower. Order of finish in a race, top 40 songs, top 25 football teams, etc. Can you answer this exercise? Nominal variables have name only. Ordinal variables have A. Name only, B. Order only, or C. Both name and order. The answer is C, both name and order. The third data type is interval. Interval is like ordinal, except we can say the intervals between each value are equally split. They are called interval variables because the intervals between the numbers represent something real. Interval scales not only name and order, but also have the property that equal intervals in the numbers measured represent real equal differences in the variables. The most common example is temperature in degree Fahrenheit. The difference between 29 and 30 degrees is the same magnitude as the difference between 78 and 79 degrees. Can you answer this exercise? Interval variables have A. Name, order, and equal intervals, B. Order only, C. Name and order only, or D. Name only. The answer is A, name, order, and equal intervals. The fourth data type is ratio. Ratio has all the properties of interval plus a real absolute zero. The value of 0 represents the total absence of the variable being measured. Some examples of ratio variables are length measures, time measures, blood pressure, age, and common measures of mass, weight, and volume. They are called ratio variables because ratios are meaningful with this type of variable. It makes sense to say 100 feet is twice as long as 50 feet because length measured in feet is a ratio variable. Can you answer this exercise? Ratio variables have A, equal intervals, B, name, C, order, D, a real zero, or E, all. The answer is all. Now we will talk about descriptive statistics and how to apply them to the 4 data types. Descriptive statistics is a term used for the analysis of data that helps describe, summarize, or show data in a meaningful way. There are 2 types of descriptive statistics. Measures of central tendency, which include mean, median, mode, and measures of spread, which include range, quartile, variance, and standard deviation. Measures of central tendency is defined as the frequency distribution for a group of data. The frequency distribution is simply the distribution and pattern of marks scored by the 100 students from the lowest to the highest. We can describe the central position using a number of statistics including the mode, median, and mean. Let us look at each of these individually. The first measure of central tendency we're going to discuss is mode. Mode is the number, item, or category which appears most often in a data set. In the example, the mode of 424322 is 2 because it occurs 3 times, which is more than any other number. Normally the mode is used for categorical data where we wish to know which is the most common category. Can you answer the exercise? In the chart, which method of transportation represents the mode? Car, train, bus, or tram? The answer is bus. The next measure of central tendency we are going to discuss is median. The median is the middle score for a set of data that has been arranged in order of magnitude. The median is less affected by outliers and skewed data. In order to calculate the median, suppose we have the data below. The numbers in the data are 65, 55, 25, 93, 87, 43, 99, 73, 78, 14, and 100. When we rank them in order from smallest to largest, the median or middle value is 73. If we have an even number of variables, then the median would be the average of the 2 center numbers. I removed the 100 value from the data set to give us an even number of values. The middle 2 values are 65 and 73. Therefore, the average of the 2 values is your median. 65 plus 73 divided by 2 equals 69. The last measure of central tendency to discuss is mean. The mean is the average. The mean is equal to the sum of all the values divided by the number of values in the data set. In order to calculate the mean, suppose we have the data below. Using the data set from the previous slide, the sum of 65 plus 55 plus 25 plus 93 plus 87 plus 43 plus 99 plus 73 plus 78 plus 14 plus 100 equals 732. 732 divided by 11, the number of values in the data set, equals 66.5454. Therefore, the mean is 66.5454. The mean has one main disadvantage. It is particularly susceptible to the influence of outliers. These are values that are unusual compared to the rest of the data set by being especially small or large numerical values. Now let's look at an exercise. Can you match the type of variable to the best measure of central tendency? The type of variables are nominal, ordinal, interval/ratio, not skewed, or interval ratio that is skewed. Remembering that skewed means the data set is not evenly distributed. There are outliers that will influence the mean. The central tendencies you're going to match to are mean, median, and mode. The best central tendency for nominal is mode. The best central tendency for ordinal is median. The best central tendency for interval or ratio, where the data is not skewed, is mean. And the best central tendency for interval ratio data that is skewed is median. Now let us talk about the second type of descriptive statistics, measures of spread. Measures of spread are ways of summarizing a group of data by describing how spread out the scores are. For example, the mean score of our 100 students may be 65 out of 100. However, not all students will have scored 65. Rather, their scores will be spread out. Some will be lower and others higher. Measures of spread help us to summarize how spread out these scores are. To describe this spread, a number of statistics are available to us, including the range, quartiles, variance, and standard deviation. A measure of spread sometimes is also called a measure of dispersion. It is used to describe the variability in a sample or population. It is usually used in conjunction with a measure of central tendencies, such as the mean or median, to provide an overall description of a data set. The spread of the values can be measured for quantitative data, as the variables are numeric and can be arranged into a logical order with a low-end value and a high-end value. Now let us look at an example of measures of spread. On the right side of the screen are two data sets, Dataset A and Dataset B. Dataset A consists of the following values: 4555, 6666, 7778. And Dataset B consists of 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, 10, 11. For both datasets, the mode, the most frequent value, the median, the middle value, and the mean, the average, is 6. If we just look at the measures of central tendency, we may assume that the datasets are the same. However, if we look at the spread of the values in the graph, we can see that dataset B is more dispersed than dataset A. Used together, the measures of central tendency and measures of spread help us better understand the data. Continuing with our discussion of measures of spread, let us define the common measurements: range, quartiles, variance, and standard deviation. Range is the difference between the highest and lowest scores in a data set and is the simplest measure of spread. Using the data from the median example with our data sets containing 14, 25, 43, 55, 65, 73, 78, 87, 93, and 99, the range would be 85. 99 minus 14 is 85. Continuing with our discussion on measures of spread, let us talk about quartiles. Quartiles divide an ordered dataset into 4 equal parts and refers to the values of the point between the quarters. Using the same dataset as the range example, there are 10 data points. 1/4 of the data occurs every 2.5 data points. From our dataset, 14 and 25 are in quartile 1. 43, 55, and 65 are in quartile 2. Quartile 3 is comprised of 73, 78, and 87, while 93 and 99 are part of quartile 4. To find the high and low of each quartile, one must average the two numbers where the quartile point falls. The high end of quartile 1 is the average of 25, the highest data point in quartile 1, and 43, the lowest data point in quartile 2, divided by 2, which equals 34. Therefore, all values that are equal or less than 34 are in quartile 1. Values greater than 34 to 69 are in quartile 2. Values greater than 69 to 90 are in quartile 3, and values greater than 90 are in quartile 4. The next measures of spread are variance and standard deviation. The variance and the standard deviation are measures of the spread of the data around the mean. They summarize how close each observed data value is to the mean value. In data sets with a small spread, all values are very close to the mean, resulting in a small variance and standard deviation. Where a data set is more dispersed, such as dataset B in the chart, values are spread further away from the mean, leading to a larger variance and standard deviation. The variance in dataset B equals 9.17 and dataset A equals 1.17. The standard deviation, which is the square root of the variance for dataset B, equals 3.03 compared to the 1.08 for dataset A. Let's summarize what we have covered today. First, we talked about the context of data. Then we talked about the 4 basic data types: nominal, ordinal, interval, and ratio. Then we moved on to the 2 types of descriptive statistics: measures of central tendency, which include mean, median, and mode, and measures of spread, which included range, quartiles, variance, and standard deviation. Thank you for reviewing Data Talk. We hope you have found it to be helpful and will join us for upcoming webinars. If you wish to contact us, you may do so through the mail at IDEA Data and Research, University of Arkansas at Little Rock, 2801 South University Avenue, Education 209, Little Rock, Arkansas 72204. Our phone number is 501-683-7219. Our fax number is 501-569-8238. If you have any questions, you can contact Dr. Jody Fields at jafields@ualr.edu.